Mm. All right, welcome everyone. Going to give folks a few moments to join. All right, looks like we've got a bunch of people jumping in already. So thank you everyone for joining today for Designing with Fixed Aluminum Ladders for Commercial and Industrial Projects. It's presented by Michelle Murray with the O'Keefe's team. And we've got a bunch of other folks from the O'Keefe's team here as well. Their cameras are hidden right now, but they are on standby to help answer any questions that you have throughout today's presentation. So I really want to encourage folks to ask any questions using the Q&A throughout the presentation. We'll have some time to talk through some of those questions live towards the end of the webinar. We'll also have a record of all of those questions. So if they don't get answered live, we'll be able to follow up with you after today's event. If you've joined webinars with us in the past, you know we typically do a quick introduction at the beginning where we show you how to get to the O'Keefe's page on Acelab. We're going to skip that for today. We might have some time to do that at the end, but just want to let folks know to keep your eyes peeled for the chat. I'll be sending over a link to the O'Keefe's page where you can get in touch with their team directly, explore some more about their products, access downloads. I'll also send over a link to my colleague's meeting link if you would like to schedule a quick demo with Acelab and learn some more about all of the resources we provide for architects and designers, how to use our platform to research building products and organize your digital product library. So just keep your eyes peeled for the chat, grab anything that might be helpful from there before you head out for the day. Last thing for me is that this is a CEU approved course. We did ask for AIA numbers upon registration. We'll also send over a form through the chat momentarily in case you're worried you didn't submit your AIA number or you want to indicate your need for a certificate, you can fill out that form. All right. I believe that should be it for me. Michelle, whenever you're ready, feel free to go ahead and get started.
Okay, thanks so much, Bo. As she said, I am the architectural sales rep for O'Keefe's, and we are going to look at designing for fixed aluminum ladders. Bo, can they see my screen now?
Yep, yeah, they can see.
Okay, great, perfect. Okay, so this is designing with fixed aluminum ladders for commercial and industrial projects. O'Keefe's is a leading manufacturer of aluminum ladders. This includes fixed access, ship, cage, and custom ladders. The company started in 1939 and has expanded its manufacturing capabilities to include other products such as fire-rated glass and framings through Safety First and specialty doors through Titan Metal products. But today we're going to focus on aluminum ladders. This is an AIA accredited course. You'll get one learning unit for health, safety, and welfare. And for housekeeping, this is also a copywritten presentation. So our learning objectives today, we're going to look at the different materials used for ladder construction and identify the pros and cons of each of those materials. We'll dive into the codes and standards relevant to the design and specification of safe, usable ladders based on individual applications. We're going to look at available standard and custom options, and then accessories that designers can use today. And then finally, look at some case studies on how designers have used these products in real world settings through case studies. So jumping right in, reviewing the different materials for ladders. These are the types of ladders available: wood, fiberglass, steel, and aluminum. We're going to look at the differences between these two, or these four. So first you have wood. It is a great popular choice since it's affordable and readily available. As long as you take proper care of them, wood ladders can last a long time. When they're dry, they're great as a non-conductor of electricity, which makes them a top choice with fiberglass for work that may have electrical hazards. Despite this, wood ladders are not appropriate for all industrial or commercial environments, as they're prone to rot, fungus, mold, or pest. FRP, which is a fiberglass reinforced plastic, is a composite material that is made of fine glass fibers and a polymer resin. Among the different ladder types, they're considered to be the newest. They're lighter than wood ladders, but more heavier and more dense than an aluminum ladder. They are also non-conductive and corrosion resistant. In comparison to aluminum ladders, fiberglass ladders can be more difficult to work with because of their weight. Installation difficulties aside, the high cost of fiberglass also serves as one of its major disadvantages. Steel ladders are good to use in rough environments, such as a warehouse or industrial facility. However, it's important to note that steel ladders are not corrosion resistant. If you plan to install it outdoors, you'll need to have it galvanized, painted, or made with a stainless steel to meet ladder regulations. This can add to the ladder's expense. Aluminum ladders are very popular in commercial and industrial applications as they're durable, lightweight, and affordable. Moreover, you don't have to worry about maintaining aluminum ladders because they are corrosion resistant. Aluminum is typically more expensive compared to regular steel ladders, but cheaper than stainless steel or galvanized steel ladders. So in this section, we're going to go over some of the differences between aluminum and steel ladders in ladder fabrication. Aluminum, as we talked about before, it's lightweight, high-strength material. Steel ladders are heavier, which makes them difficult and expensive to transport and handle. Aluminum is resistant to rust and corrosion. Steel ladders can rust over time and eventually may have to be replaced, which adds to the cost and inconvenience. In addition, if a rusting ladder is not noticed or attended to, it can present a hazard to anyone who attempts to use it in a corroded state. To combat corrosion, steel ladders are either galvanized or made with stainless steel. This makes them more expensive than aluminum ladders, which naturally and economically resist rust and corrosion. Aluminum ladders are also maintenance-free, thus lowering their lifetime cost and improving their lifetime dependability at the same time. Aluminum is non-spark, reducing the risk of it being a fire hazard. It is also non-magnetic, making it ideal in places where magnetic equipment is stored. Aluminum ladders are available in multiple finishes. They can be painted or anodized without losing its shine or color. Steel can be painted but not anodized. Painted finishes are more prone to wear and chipping. Top quality aluminum ladders have deeply serrated square rungs for maximum foot traction, comfort, and safety. Steel ladders typically have round rungs and are not serrated, making it less stable and potentially slippery for the person trying to climb it. Aluminum is environmentally friendly. The top manufacturers make aluminum extrusions with recycled content. An aluminum ladder can have as much as 26% post-consumer recycled content. Aluminum is also most infinitely recyclable, so if a building is altered or demolished, the ladder can be recycled one more time. The second objective we're going to look at is learning about the relevant codes and standards relevant to the design and specification of safe, usable ladders based on the application. There are a number of codes, standards, and authorities which may govern the design and use of ladders. Designers should always check to see which codes and regulations apply to every specific project, since rules vary from place to place and project to project. Designers should also remember that codes set minimum standards and that exceeding codes is simply best practice, since it means improving safety conditions beyond the minimum. Even when a code or standard may not be legally applicable, it can contain valuable design advice that can be used to ensure ladder design is safe and trustworthy. A lack of understanding of code requirements can lead to flawed specifications and installations, which in turn can pose a dangerous situation that would have to be removed at the cost of money, injury, or loss of life. The International Building Code, or the IBC, contains regulations about practices used in commercial construction related to all buildings except 1- and 2-family dwellings and townhouses up to 3 stories. The IBC applies to new construction and renovations. It's a model code, and it's up to each individual state or jurisdiction to determine what version or sections to adopt. When it comes to accessing the roof, the IBC differentiates between occupied and unoccupied. An occupied roof is accessible to all building occupants. Some examples would include a rooftop lounge, a bar, a pool area, or a gathering space that's accessible to the public. It's considered a story within the building like any other enclosed story. Therefore, the same means of egress would apply. An unoccupied roof is accessible only to maintenance or construction personnel, to perform roof repairs or maintenance, or to service mechanical equipment on the roof. For the purposes of this presentation, we're going to focus on the unoccupied roof. OSHA stands for Occupational Safety and Health Administration. The importance of OSHA lies in its ability to protect workers from potential hazards and risk in the workplace. OSHA standards are rules that describe the methods employers are legally required to follow to protect their workers from hazards. OSHA standards are the rules that describe the methods, OSHA requirements for fixed ladders appear in section 29 CFR 19.23 for the ladders, and for ship ladders, they appear in section 1910.25 under stairways. ANSI stands for the American National Standards Institute. The ANSI does not develop standards. It establishes a context for them to be created by Standards Developing Organization, or SDOs. ANSI standards, however, can be adopted by OSHA and thus become law. This is a short video that shows the difference between OSHA and ANSI.
What is the difference between OSHA and ANSI standards? OSHA standards are mandatory and regulate how employers must provide safe working conditions in the workplace. ANSI standards are voluntary and are related to the products used and to the general consumer population. ANSI standards may be adopted by OSHA as law. Applying both types of standards lead to fewer injuries and deaths and an overall better workplace environment.
Okay, now that we've looked at some codes, we're going to look at objective number 3 and identify the available standard and custom ladder options and accessories that designers can use today. The ladders are typically found in Division 5 in the Metals of Construction project specifications. Depending on the project or the spec writer, these are the 4 sections that you may find for your ladders. The most common types of ladders are fixed access ladders, cage ladders, and ship ladders, or sometimes referred to as ship stairs. Other common applications include stairs, extended platforms, catwalks, and ramps. So we're going to get into the anatomy of the fixed access ladder. They're all going to share the same feature. They're going to have rungs, side rails, and brackets, either wall or floor brackets. There are several alternate or additional bracket options. You could have the off-the-floor mounting brackets used as an alternate to the standard floor mounting bracket when obstructions are present that prohibit the ladder from being attached to the floor. In this case, the ladder is attached securely to the wall. Extended and intermediate brackets for ladders with a back set beyond the standard 7 inches up to 18 inches. And an additional intermediate bracket provided every 10 feet to anchor the ladder securely to the wall. Going back to the anatomy of the fixed access ladder, some fixed access ladders will have a roof over rail extension. Some will have a platform with return. Some will have a platform without a return. We're going to look at some codes now. In the next couple of slides, we're going to discuss fixed access ladder code requirements, noting the similarities and differences between OSHA, ANSI, and IMC. For rung spacing, OSHA needs to be between 10 and 14 inches, whereas the ANSI IMC standard needs to be 14 inches. For rung width for the OSHA ANSI standard, you need to be a minimum of 16 inches. And for IMC, it needs to be a minimum of 18 inches. For the side rails, OSHA and ANSI are 42 inches. And for IMC, it's a minimum of 30 inches. Grab bars, the OSHA ANSI is 15 inches minimum. For the backside clearance or the back set, the OSHA ANSI is 7 inches, except for elevator pits, which is 4.5 inches. A little bit of a busier slide. This slide summarizes the different clearance requirements for fixed access ladders that we just saw in the previous slides. So you'll see the minimum 30-inch climbing side clearance for the OSHA ANSI IMC standard. You'll see the 10 to 14-inch rung spacing. You'll see the minimum 7-inch back set. And then for the OSHA ANSI standard on the side rails, it's a minimum of 16 inches, where IMC is a minimum of 18 inches between the side rails. And lastly, the 15-inch minimum clearance, side clearance for OSHA, ANSI, and IMC. When you talk about the load on the rungs for OSHA and ANSI, it's 250 pounds, and the IMC needs to be a minimum of 300 pounds. The pitch of a fixed ladder is important. OSHA, ANSI, and IMC, the range is between 75 and 90 degrees from the horizontal. Sometimes fixed access ladders can have a cage or a well. It's an enclosure mounted on the side rails of a fixed ladder or fastened to a structure behind the fixed ladder, which surrounds the climbing space of the ladder. Here's a video that explains the OSHA ruling on cage ladders.
What are OSHA's fixed ladder fall protection requirements? According to OSHA, fixed access ladders that extend more than 24 feet must have ladder safety or fall arrest systems. Previously, OSHA required cages for fixed ladders taller than 20 feet. Fixed ladders installed before November 19, 2018 must be equipped with a personal fall arrest system, a ladder safety system, cage, or well. Fixed ladders installed on or after November 19, 2018 must be equipped with a personal fall arrest system or a ladder safety system. Cages are not permissible as a means of fall protection for newly installed or replacement fixed ladders. By November 19, 2036, cages will no longer be accepted as a fall protection system on any fixed ladder.
So just to reiterate, today, if the fixed ladder is under 24 feet, a cage still can be used as fall protection. But after November 19th, 2036, cages will no longer be accepted as fall protection on any fixed ladder. So some of the options that you'd have instead of a cage, you can have a fall arrest system. It's a cable-based system with a shuttle that connects a worker's harness, D-ring. The shuttle moves with the worker as they climb up or down the ladder. And if the climber slips, then the traveler engages in the cable and arrests the climber's fall. So this ladder here has an image of a fall arrest system. Some additional accessories and options for fixed access ladders are a safety post. This provides the climber with something to hold on to as they pull themselves through the hatch. Landing platforms. OSHA requires landings for climbs longer than 50 feet. If there's no fall arrest system, they are placed every 20 feet. Landing platforms can be used for various purposes, including switching from one ladder to another when the ladders are offset to go around obstructions, or as a resting place in long climbs. A security door will prevent the unauthorized access to the ladder for security purposes. So next, we're going to look at the anatomy of a ship ladder. Sometimes they're called crossover ladders as they are used to cross over mechanical equipment or connect separate buildings. All ship ladders will share these same features: handrails, side rails, treads, and mounting brackets, either floor mounted or an optional seismic bracket. Sometimes the ship ladder can have a roof over rail extensions, which provide easy roof or mezzanine access with no existing handrails. It can have a platform without a return, again, providing easy roof or mezzanine access. It can have a platform with a return, again, providing easy roof to roof or crossover access over pipes, ducts, or equipment. As we move on to some codes for ship ladders, we're going to look at the similarities and differences again between OSHA and the IBC. For your tread depth, you need a minimum of 4 inches for OSHA and 5 inches for IBC. Your tread width, OSHA is 18-inch minimum, and for IBC, it's 20 inches. The risers will be between 6.5 to 12 inches for OSHA, and for IBC, a maximum of 9.5 inches. For your handrails, the OSHA and IBC, they are required for both codes on the ship ladder. The angle for the ship ladder is between 50 degrees to 70 degrees for OSHA. The clearance for OSHA and IBC is minimum 6 foot 8 inches in vertical clearance. For the loads, OSHA is 1,000 pounds. And for IBC, you need to reference the code for fixed ladders. And finally, all types of ladders can be ordered in a range of colors, including the OSHA safety colors below. They can also be painted in custom colors. Okay, for learning objective 4, we're going to look at some case studies where designers have used these products in real-world settings. This is a custom rolling stair supplied to San Francisco International Airport to help maintenance staff access and clean the skylight over the terminal. Because the custom rolling stair goes across the skylight, it had to be both lightweight and high strength, which aluminum is. And the proximity to the salty air near San Francisco Bay and the exposure of the stair to the elements meant aluminum was chosen for its corrosion resistance properties. This is a pharmaceutical laboratory in the Bay Area, needed a custom platform to access equipment safely. It also needed to be 48 inches off the ground to clear pipes and other equipment on the floor. What you're looking at is a rendering of the actual product supplied. This is the same project. In a sterile environment, aluminum was the ideal material due to the frequent washing and sanitizing performed on all surfaces, and helps the laboratory meet OSHA and ANSI standards for this type of application. This custom crossover ramp was used to cross over mechanical equipment, such as air ducts and piping, without the worry of tread steps. This becomes useful when moving equipment around using the ramp. Guardrails are placed on both sides for safety standards and comply with OSHA and ANSI safety standards pertaining to restricted walkways. This product is shown in the factory prior to shipment. This is an example of an aluminum crossover using a ship ladder platform configuration that is custom designed to provide access over a major obstacle on a rooftop. This is a situation where a seismic bracket may be required. This custom ship ladder with landing platform was used to create a safe and easy way to access a 35-foot tall water tank. It was installed on the Big Fork water tank in Big Fork, Montana. The customer sent in their preliminary design and worked with our engineering team, and we provided calcs. The mid-span supports have some cross bracing that provide additional support for the long span. Aluminum was preferred over steel for corrosion resistance and low maintenance. This project was shipped in 3 sections, 2 ladders separate and 1 platform separate, and then installed on site. This is Lincoln High School in Kent, Washington. We provided a custom ship ladder with a custom ramp. What you're looking at is a rendering of the actual product supplied. We provided 2 of these for their roof. They needed a way to access the other side of the light well, which was 50 feet long. We provided a custom ship ladder with custom ramp versus a stair because the angle is shallow. The ramp side has ridges to prevent slipping. Ladder side has treads, handrails provided for safety. Structural calculations were also provided. O'Keefe's designed a truss system on the ramp side to support the long spans so that the ramp would be able to support itself without touching the sloped roof. And overall, it's about 19 feet in length. This was shipped pre-assembled for ease of installation, the ramp in one section and the ladder and platform in one section. This is the Twin Valley Behavioral Health in Columbus, Ohio. This custom platform with access ladder was used to access the air handling units on the roof. What you see is a rendering of the actual product supplied. 30 of these were used on this project. The customer provided their requirements to access the units, and because the platforms could not be anchored to the roof, as the warranty for the roof would be negated. So a truss system was designed to anchor the platforms to the concrete steps instead. Calcs were submitted and the customer reviewed everything and approved the design. These were shipped pre-assembled for ease of installation, platform and rails assembled. The latter part was assembled on site and they were all craned to the roof. This concludes the continuing education portion. If you have any questions, please let us know.
All right, awesome. We definitely have some questions coming in, and a reminder for anyone who has not submitted a question, you can do that through the Q&A box, and we'll have some time to answer that live. So if it sounds good, I'll just kind of read them off. We can start at the top, and I know we've got Adam on as well to help out with answering some of these too. So let's see. All right, some things about here. All right, looks like there's 2 questions about certificates and AIA attendance. All right, so for AIA attendance, we did ask for AIA numbers upon registration. There's also a form in the chat. It's the first message we sent in the chat. You can submit your AIA number through that. You can also request a certificate through that as well. All right, next up, what are the requirements for intermediate landings? UBC requires landings every 12 feet of elevation.
Yeah, I mean, based on whatever the specifications require is what, we have no problem fabricating to. Typically, landing platforms are more so on 50-foot sections. Like we said, unless no fall arrest is included, then they would be 20-foot sections.
All right, awesome. And then it looks like we've got a few requests for a copy of the slides. Is that something that y'all would be willing to provide?
So we have an actual handout because I know the presentation is very code heavy. There's a lot of information in, you know, a 40-minute presentation. We have a handout.
We sent that over actually. So we will
Yes,
send that in the follow-up email anyway.
perfect. Great. Yeah, so we will go ahead and get that out to everybody because there is a lot of code information.
Perfect. Yeah. That handout is super helpful. We'll send that out in a follow-up email. So that should answer, I think, all of the questions that you might need.
Perfect.
All right, great. Looks like there might not be any other questions right now. So I'm going to take over screen share for just a moment
Okay.
while anybody else has any other questions, and just go over some of the stuff that I usually cover at the top that we skipped over for today. So just want to show you guys some great resources for after today's webinar if you're looking to learn a little bit more about the O'Keefe's team and their products. You can use this search bar at the top. So everyone who has a webinar account with us has an Acelab account. You can jump over here to explore a bunch of our free resources. Great place to come is just to use the search bar in the top. You can start typing in the name of any brand, any product. It'll cross search between all of our resources. And you can head over to the O'Keefe's brand page on Acelab. Scrolling down here, you can get in touch with their team directly through this, explore some more about their company, as well as explore some more about their products. You can save these to your account so that you can come back to them for future reference. And we've got a bunch of great resources here. If you open up these product pages, you can download specs, CAD, BIM files, view some great installation photos, learn some more about the products, construction details, all of that good stuff. So this is a great place to come after the webinar if you're looking to get some more resources that are product specific. We also shared a link to the O'Keefe's page in the chat as well. So feel free to grab that so that you can head to it directly. All right, looks like we've got another question in here. Is it possible to have the ladder finish as anodized?
Yes, we do offer a clear anodized finish. We used to do bronze anodized finish, but due to some irregularities that were coming out, we kind of veered away from the bronze ano finish, but we have a powder coat color to match a bronze ano if that's needed.
Got it. Awesome. All right, great. Looks like that might have wrapped up our questions for now. So we'll hold on for a few more minutes and I'll go over a few other housekeeping items. As you're leaving today's webinar, there's going to be a quick post-event survey. Feel free to add any questions to that or any feedback about how today's webinar was for you. That's super helpful for us. And any questions that you list there, we'll have a report of those so that we can follow up with you there as well. All right, great. Awesome. Well, if no one else has any questions, I think we can give folks some more time back in their day. But
Great.
I really want to thank you, Michelle, for a great presentation.
Thank you.
We appreciate it.
Appreciate
Thank
it.
you, Adam, for being here to answer questions.
Absolutely.
And thank you, everyone in the audience, for coming out today and joining us
Thank
for
you.
today's webinar.
Thank you so much.
All right. Thanks, everyone.
Bye. Thank you,
Bye.
everyone.
Bye.